Hi. Right now I want to cover with you how to evaluate logs. This will be the first video of this type, so it'll be more basic than the one that'll follow. So to begin with, we know that a logarithm is an exponent, and when I say log to base 3, so this is the base, so I say log to base 3 of 3. I'm basically always asking what power do I raise this to get this. So I'm saying 3 to the what equals 3. And of course, raising things to the first power always gives you itself. So that's equal to a 1. We just report the exponent. A logarithm is an exponent. Okay, now over here, if I said log to base 5 of 5, that would equal, well, what power do I raise 5 to get 5? The first power. And in fact, would it matter what number I put here, so long as the same number I put right here? 7 to what power gives me 7? Notice too, by the way, that the base is always written below the word log, and the argument is always written level with the word log. Make sure you have them stay that way. But I think we've discovered a property that when these match, this is always going to be a 1. So as we discover properties, you can say the log to any base whatsoever of itself equals 1. So we just learned a particular property of logs. Okay, I'm going to erase this, so if you want to screenshot it, feel free by pressing the home and the power button at the same time. I'm going to erase these, and I'm going to show you some more problems to do. I'll leave this true fact we got written up there. Okay. So, next. What about something like the log of 10? Do you notice this doesn't have a base written? Every time you see the word log written out and you don't see a number there, it means log to base 10 of whatever's sitting there. So there's one you can evaluate. It's going to be 1. So I wanted to make sure you knew when you don't see a log, when you don't see a base, it is still there. You can pencil it right in so you can see it if you want. That makes it easier to think through. So this is called the log to base 10, and in my parents' day they would have called it a common log because it was used in the days a lot before we had calculators. Okay, another fact that we want to look at. To evaluate some more logs. Log to base 3 of 1. Basically, I'm asking 3 to what power, so whatever we put in that box is our logarithm, that would give us the argument, or 1. What power do we raise things to land right on 1? Do you remember that whenever we have an exponent of 0, it always gives us 1. 3 to the 0 is 1. 5 to the 0 is 1. 17 to the 0. Any number at all other than 0 to the 0 power is 1. So if I said log to base 7 of 1, what power do I raise 7 to land on 1? 0. So basically, remember the thing we put up here is the logarithm because it is the exponent. So whenever you have the log to any base whatsoever, any base at all, of 1, b to the 0 power gives me that 1. So this is another true fact about logarithms. Finally, again, you may want a screenshot. I'm going to erase these. Always a good idea to take notes with these anyway, and that helps you process them, but and then you can use the videos to review later on. So, and again, I'll leave those two properties that we discovered right up there. Next thing. Log to base b, or actually I'll make it be a log to base 7 of 1/7 equals, what I'm asking is 7 to what power? I'm looking for an exponent. 7 to some power that I don't know comes out to be 1/7. Well, do you remember what kind of exponents? We did this in the fall. What kind of exponents we raised things to that put them underneath 1? Do you remember that this is actually not a log fact, it's an exponent fact? B to the negative n means the same thing as 1 over b to the n. So basically, when you have a negative exponent, it brings it underneath 1. The amount of the exponent doesn't change, but the n power is what's underneath, but it's the negative power that brings it downstairs. So the answer here is -1. So the answer to this question is we raise 7 to the -1 power in order to get this. Now let me look at that a little bit. Let's try another one. What's the log to base 2 of 1/4? Well, what power would I raise 2 to? See, I write it like this to help me think about it more clearly. When I'm all done, the answer is going to just be the exponent, whatever I find in the box. So first of all, you know how when we multiply 2 by itself, when we square 2, it comes out to be a 4? So basically here, raising to the -2 power, the negativeness is what brings it under 1, and the fact that it's a 2 is what makes it come out to be a 4 underneath. So let's try another one on your own here. What would the log to base 3 of 1 over 27 be? What power would I raise 3 to have the 3 crawl underneath the 1 and grow to be a 37, power-wise? Well, what power do we raise 3 to have it become a 27? 3 to the 3rd. And then what brings it underneath is if that exponent is negative. So this is -3. Oh, excuse me. Yes, -3. So 3 to the -3rd brings the 3 underneath the 1 because of that rule. And then multiplying 3 3's together is where the 27 comes from. So that concludes my basic introduction to how to do some logarithms, how to evaluate them, and we will get into more detail as we continue.